Volcanic activity is commonly perceived as a process that produces a picturesque cone-shaped structure, which periodically erupts in a violent manner. Although some eruptions may be cataclysmic, many are relatively quiescent. The primary factors that determine the nature of volcanic eruptions include the magma's composition, its temperature, and the amount of dissolved gases it contains. These factors affect the magma's viscosity. The more viscous a material, the greater its resistance to flow. When the temperatures of lavas are high, they are more fluid. As the temperature drops, the lava becomes more viscous. Magmas that produce basaltic rock contain about 50% silica and tend to be quite fluid. Thus, hot basaltic lavas tend to be quite fluid and have been known to travel distances of 150 kilometers, 90 miles, before congealing. By contrast, rhyolitic magmas, those that crystallize to form rhyolite and granite, contain over 70% silica and are very viscous. Rhyolitic lavas are very viscous and tend to form comparatively short, thick flows. Gases in fluid basaltic magmas migrate upward and escape from the vent with relative ease. As they escape, the gases often propel incandescent lava hundreds of meters into the air. At the other extreme, highly viscous magmas impede the upward migration of expanding gases. The gases collect as bubbles that increase in pressure until they explosively eject the semi-molten rock from a volcano. Thus, the viscosity of magma, plus the quantity of dissolved gases and the ease with which they escape, determine the nature of a volcanic eruption. Depending on the chemical composition of the magma, volcanic eruptions extrude various quantities of lava, gases, and pyroclastic materials. Due to their low silica content, basaltic magmas extrude mainly lavas that are very fluid and flow in thin, broad sheets or stream-like ribbons. When fluid basaltic lavas congeal, they often form a smooth skin that wrinkles as the still molten subsurface continues to advance. These flows are called pohoihoi. Another common type of basaltic lava, called aa, has a rough, jagged surface. Active aa flows are relatively cool and thick and advance more slowly than pohoihoi flows. Depending on chemical composition, the gaseous portion of most magmas is believed to make up 1 to 6% of the total weight. Analysis of samples indicates that the gases are about 70% water vapor, 15% carbon dioxide, 5% nitrogen, 5% sulfur dioxide, and lesser amounts of chlorine, hydrogen, and argon. Magmas high in silica tend to eject large quantities of pyroclastic materials. Pyroclastics are formed when pulverized rock, blobs of lava, and glass fragments are ejected from the vent. Fine ash and dust particles less than 2 millimeters in diameter are produced when the extruded lava contains so many gas bubbles that it resembles the froth flowing from a newly opened bottle of champagne. Fine debris can be blasted high into the atmosphere, where it can produce brilliant sunsets and may temporarily lower Earth's average temperature. Sometimes the froth-like lava is ejected in larger pieces. Pyroclastic materials ranging in size from small beads up to walnuts 2 to 64 millimeters in diameter are termed lapilli. This ejecta is also referred to as cinders. Particles larger than lapilli, greater than 64 millimeters, are called blocks when they are made of hardened lava, and bombs when they are ejected as incandescent lava. The eruptive history of each volcano is unique. Consequently, all volcanoes are somewhat different in form and size. Nevertheless, volcanologists have recognized that volcanoes exhibiting somewhat similar eruptive styles can be grouped together. When fluid lava is extruded, the volcano takes the shape of a broad, domed structure called a shield volcano. Shield volcanoes are built primarily of fluid basaltic lava flows and contain only a small percentage of pyroclastics. Typically, shield volcanoes have a slope of only a few degrees. In addition, shield volcanoes can be some of the largest volcanoes on Earth, as exemplified by the volcanoes of the Hawaiian Islands. Because shield volcanoes are associated with very fluid magmas, these volcanoes generally exhibit quiescent eruptions. As the name suggests, cinder cones are built from ejected lava fragments. Because loose pyroclastic material has a high angle of repose between 30 and 40 degrees, cinder cones have very steep slopes. Cinder cones are relatively small, usually less than 300 meters high, and sometimes form near or on the flanks of larger volcanoes. Earth's most picturesque volcanoes are composite cones. A composite cone is a large, nearly symmetrical structure composed of interbedded lavas and pyroclastic deposits, emitted mainly from a central vent. A composite cone may extrude viscous lava for a long period, and then the eruptive style changes and the volcano violently ejects pyroclastic materials. Composite cones represent one of the most violent types of volcanic activity. Occasionally, composite cones produce dangerous pyroclastic flows. These fiery clouds, called nuées ardentes, consist of turbulent steam clouds and ash flows that race down volcanic slopes at speeds that reach 200 kilometers, 125 miles per hour. In 1902, a nuée ardente destroyed the town of St. Pierre, killing almost all of the town's 28,000 inhabitants. In addition, composite cones often generate a type of mud flow known as a lahar. When Mount St. Helens erupted in May 1980, several lahars formed. Sunset Crater, Mount Rainier, and Mauna Loa represent large but otherwise typical examples of the three types of volcanoes. What type of volcano is illustrated in each photo? Drag the labels to the proper photographs. Although volcanic eruptions can be violent natural events and are therefore worthy of study, most magma is emplaced at depth. The structures that result from the emplacement of magma at depth are called plutons. Since all plutons form out of our view, they can only be studied firsthand after uplifting and erosion have exposed them. Plutons are generally classified according to their shape as either tabular, sheet-like, or massive, and by their orientation with respect to the host rock. They are said to be discordant if they cut existing rocks, and concordant if they form parallel to existing sedimentary beds. Dikes are sheet-like plutons produced when magma is injected in fractures that cut across rock layers. Drag the label to the correct box. Sills are tabular structures formed when magma is injected along sedimentary bedding surfaces. Drag the label to the correct box. Laccoliths form like sills, but from viscous magma, which collects as lens-shaped masses that arch the overlying strata. Drag the label to the correct box. Batholiths are the largest intrusive igneous features. Drag the label to the correct box. Batholiths can form the cores of mountains such as the Sierra Nevada.